Hi, my name is Trent, and in this video I'll be talking about solar inverters and how they work. Inverters are a very important part of your solar power system. Solar panels produce direct current electricity when they receive sunlight, but your home appliances run on alternating current. In simple terms, the solar inverter is the device in charge of converting DC power to AC power. If you connect solar panels and home appliances directly without a DC to AC conversion, your appliances will simply not work and they can be damaged. Solar inverters also have the ability to synchronise with the AC voltage and frequency supplied by the local power grid, which means both systems can operate as one. Thanks to this feature, your home can use electricity from solar panels and the grid at the same time, and there is no need to separate both sources with a physical switch. When your home appliances are consuming more power than what your solar panels are generating, the difference comes from the grid. On the other hand, when your appliances are consuming less power than what your solar panels are generating, you can send surplus power to the grid. In this case, the electricity provider gives you a credit that is subtracted from your next bill. There are many types of solar inverters, each designed with your energy needs in mind. Traditional string inverters are designed for solar systems without batteries. This type of inverter is designed to control several solar panels at once when the solar panels are wired together in series circuits, also known as strings. It's common for inverters to be sized smaller than the total system size of the solar panels. However, there is an economic reason for this. Solar inverters can be sized smaller to reduce upfront costs, and this has a minimal impact on electricity production. In rare occasions where your solar panels generate more watts than the inverter can handle, the extra power is simply clipped off. This only happens for short periods during the sunniest days, and the cost of a larger inverter is more than the extra savings it offers. Microinverters are smaller devices that are wired directly to solar panels. This means each solar panel operates independently from the rest, which is an advantage on rooftops with uneven shading or complex geometry. However, microinverters are also more expensive overall since you need one for each panel. For example, you need to use 20 microinverters if you have 20 solar panels. When solar panels are connected in strings, they become dependent on each other. This means all panels will be affected if one of them is malfunctioning or covered by a shadow or shade. You can also have issues if solar panels with different orientations are wired together. Microinverters eliminate shading and orientation issues by making each solar panel independent. However, you can achieve the same effect by simply using a smart layout. A qualified provider like Install Solar can identify the best areas for your roof. And solar panels are grouped according to their energy production profile. In this case, microinverters are not necessary, and you can save on installation costs by using a traditional string inverter. String inverters can be used with power optimizers, and this type of inverter can be considered a mix of both the standard string inverter and a microinverter. There is a central inverter that converts the DC power coming from the solar panels, but the system also uses an individual power optimizer for each panel. As you might guess, solar systems with power optimizers are also more expensive since there is an additional device connected to each panel. Some manufacturers offer inverters that can operate with or without optimizers, giving solar system designers more flexibility. If your solar panels can be arranged into a smart layout that prevents shading and orientation issues, DC optimizers are not necessary and the inverter works like a traditional unit. Hybrid inverters are compatible with both solar panels and batteries, and they are often described as battery-ready inverters by manufacturers. If you want a solar system with energy storage capacity, a hybrid inverter is what you'll need. A hybrid inverter is recommended if you plan to install solar panels in the short term and you are considering batteries in the future. The unit can operate as a traditional solar inverter initially, and later the battery system can be connected and configured. On the other hand, if you already have solar panels with a traditional inverter, there are two ways to add energy storage. You can upgrade to a hybrid inverter and connect the existing solar panels and the new battery system to the same unit. This is called DC coupled system since solar panels and batteries interact using DC power, connected to the same inverter. Or you can install a separate battery system with its own inverter, and the existing solar panels and inverter will continue operating without the changes. This is called an AC coupled battery system since the solar array and battery system are connected independently to your AC installation, each with its own inverter. A DC coupled solar battery can achieve higher efficiency since there are less power conversions involved. An AC coupled battery loses some efficiency because there are more power conversions between DC and AC. However, an AC coupled battery is easier to install if you already have solar panels with a traditional inverter. Battery inverters are designed exclusively for batteries, as you might guess from its name. There are two main ways to use battery inverters in solar power systems. The first is adding energy storage to an existing solar system. As mentioned before, if you already have solar panels with an inverter that is not battery compatible, you can install an independent energy storage system with a battery inverter. The second is converting DC power from a battery system that charges with solar panels. Off-grid installations often have solar panels that are used exclusively to fill batteries using a charge controller. In this case, a battery inverter is used to convert the DC power from those batteries into AC. In other words, battery inverters don't interact directly with solar panels. However, they have applications in AC coupled battery systems and off-grid installations. A battery inverter is also useful when you need to add energy storage to a solar panel system with microinverters. In this case, the DC power produced by each solar panel is converted to AC at the source, which means you don't have the option of a DC coupled system. However, you can easily set up an AC coupled storage system with its own battery inverter. And finally, we have the multi-mode inverters. Hybrid and battery inverters mentioned earlier can power small and medium appliances off-grid, which makes them useful during blackouts. However, they are not designed to start larger devices like air conditioners and electric water heaters. If you plan to go off-grid permanently with solar panels, you need a multi-mode inverter. This is a more powerful type of inverter and it is suitable for 24/7 off-grid operation. Multi-mode inverters are versatile since they can also operate as grid-tied inverters. As you can see, there are a lot of different types of inverters. Here at Install Solar, when we size your solar system, we also provide you with recommendations for the best inverter to suit your needs. In the next video, I'll be talking about how to choose a solar inverter that suits your system.